Okay, nerds, this is an intro to string theory. I'm working towards an explanation of Sheldon and Amy's Nobel Prize win in the Big Bang Theory, but before we get there, we need a bit of an intro to string theory. So our current best model of nature is what we call the standard model of particle physics, and it describes how subatomic particles interact with each other and the fundamental forces of nature to create all of the matter that we see around us. It uses quantum mechanics to describe this behavior, and it has passed every test put in front of it for the last 100 years. But there's one problem. In 1917, Einstein put forward his theory of general relativity. Now, this model describes how our universe curves and warps depending on mass and energy, and how this mass affects our perceptions of space and time, and we call the effects gravity. So if the standard model describes all of the fundamental fields that exist in nature through the quantum field theory mathematics, then it should be able to describe this field, the gravitational field, that connects to the foundation of what space-time is. Well, it can't. Now, this isn't to say that the standard model is wrong. Like I said, it has passed every test put in front of it for a century, but it's likely incomplete, maybe. The big question that people focus on in trying to complete this is to find a way to describe gravity using quantum mechanics. Now, to explain how gravity exists, how it interacts, how it behaves on a subatomic scale. There are a few ideas about how to do this, and one of the most famous ones is string theory. Now, a thing about string theory here is that it's not just one idea, it's a collection of ideas that describes our universe being made up of strings instead of what we call particles. Now, this wouldn't mean that the standard model is wrong, like I said, it just adds to it. So our current understanding and evidence shows the smallest objects to be subatomic particles like quarks and electrons. The suggestion with string theory here is that all of these particles are actually made up of the vibration states of tiny one-dimensional strings. So string theory proposes that our universe is made up of many more small dimensions of space. Currently it's at like 10 or 11 in total instead of our standard 3. Now, in these tiny curled up little dimensions, these one-dimensional strings will vibrate, they'll twist, they'll fold, and the effect of these actions is what we then interpret as everything around us, from electrons all the way up to gravity. So is it a theory? It's string theory after all, is it a theory? Well, in this sense, theory relates to it being a mathematical model in theoretical physics. It's not just a theory the way we talk about this in our everyday language, but it also isn't an evidence-based scientific theory like the theory of evolution. What this means, kind of, is that in theoretical physics, it's entirely possible that string theory might be true, and there is support for it in mathematical tests, but we would need physical evidence to show that it is in fact a fundamental theory of nature. Not only do we not have any physical evidence, it's also become pretty clear that getting physical evidence isn't something we can do with our current capabilities. And another slight problem with string theory is that some of the things that it predicted would be the case when we fired up the LHC haven't actually come to pass, which throws into question as to whether it will actually prove to be the correct model or not. For now, we don't know. So yeah, that's your intro to string theory. Like I said, this was this is kind of connected to my Megalopolis series, but also I realize all of the topics that we're talking about with this directly relates to the Sheldon and Amy Nobel Prize in Big Bang Theory, so it's something I've been wanting to cover for a while, so I think we might now have all the info we need. So yeah, coming soon. Stay nerdy.